So hi guys, and we continue and our pricing a European call option, and we consider backwards method. And for this method, the first step it is to define payoff function, and it's just this value minus strike price, so 122 and 50 minus 100, 107 minus 100. But if from this we deduct 100, it will be negative value, so we write 0. Yes. um, After that, we would like to get option price in this node, and for this we consider this one period model and define the option price as discount mathematical expectation from this payoff function 22, 5 and 7 respect to risk neutral measure. After that, from this one period model, from this one period model, and so on. After this, we consider this one period model and this period model, and only at last step we consider this one period model, and we can get the option price, and it's as we estimate the premium of all option. It is the first way, and we can do this using Excel. For this, first we construct stock price. For this, we write in cell 100. After that, we multiply it by D and stretch. Yes. After that, in this cell, we multiplied 100 but U and stretch. And no, it's clear, yes. But for European option price in this column, the formula is this column minus K. After that, in this cell, we write formula this multiply Q plus this multiplies QD divided by 1 plus R and stretch and so on. I think it's not difficult. And what's interesting that you see this stock price and this stock price, it is the same, but for constructing option price tree, this and this K 95, but the interest rate in this case, in up case, is 2%, but this 4%. And for 4%, the option price is more than this. And maybe it can surprise. The second way, it is we can write these probabilities, yes, for finish step probabilities, and after that we can find this product, this value multiplied to this multiplied to this, and to find the sum of this, and it is as mathematical expectation. And after that, to find discounted mathematical expectation. It is the second way. There are the third way, and for the second way, sometimes it's quite tricky to find what is the probabilities and what is the values. So there are analytical formula, and its formula is called Cox-Ross-Rubinshtane. And this formula, if you would like to find option price, and we know the initial price, we know the strike price, and then number of steps. So this fair price we can find as discounted mathematical expectation respect to risk neutral measure, discounted from Pio function. And what's Pio function? It is Sn minus k if Sn more than k and t0 if Sn less than k. And what we know for mathematical expectation, we need to know value at the end of period, yes, and probabilities. But probabilities, it's binomial probabilities, and these probabilities we can compute using Bernoulli formula, and we write this. Uh, we don't write C, we write instead C this bracket. Um, After that, you see that we we don't want write max function, and after that we write only this difference, but in sum we write that the sum will be only when S and K will be more than K capital, only in this case. No, it's easy. It's easy. And you remember that at any point of this tree and any node, we can write S and K as S multiplied U to the power G we write yes and D to the power n minus G. And after that, we can this formula rewrite as this multiplied S minus all this multiplies K capital. This K is strike price. So it will be this minus K on all this, yes? K, this formula and 1 plus R to the power n. It's clear. But this, we can rewrite this as this 1 plus R to the power n. We can rewrite as 1 plus R to the power K or G and multiplied 1 plus R to the power n minus K. But this is the same. QU multiplied U to the power K and D to the power n minus K. And that's all. And that's all. Because after that, we can denote this as PU, this as SPD, and this we write that this price should be more than K, but we can define this index when this equality will be true. So 4.8 is formula Cox-Ross-Rubinshtane, and you can see it in this slide. And I would like to say that after this formula, after Cox-Ross-Rubinshtane, the traders used this formula without this sum. So if traders wanted to estimate option price, then do follow from S minus K divided 1 plus R to the power n. Understand? So without this sum, and this sum, it is probabilities coefficient, in fact, in fact. And the value of this formula exactly in this sums, in this probabilities coefficient, because this formula S minus K divided 1 plus R to the power N, um, no, no always. And we can write a formula for put option. It's not easy, and we can deduct this formula. And e.g., it is how we find how we solve this quality S and K more than K. So it is S. Oh, what is this? Uh-huh. So we can write this equality as S U to the power G, okay, D to the power N minus G, more than K. And how we can solve this and find this G? What do you think? How we can solve this respect to G, this G? Do you hear me, Christina? No?
We hear.
Thank you. But it's difficult for you, yes?
Yes, a little bit.
Little and a bit difficult. What's about Igor? Igor, do you hear me? No. Alexandra? Alexandra Harchenko, do you hear me? Yes, so maybe it will be your homework because it's school algebra. So if we solve this equality, we can find this index, but it's your homework. And it's clear that these formulas have a link, yes, because because they are similar, but we can to add this or to distract this or to multiply this. But if we distract this, so we can find difference between this and this. So if we from this distract this, what it should be? um, minus minus, it will be plus. Yes, you see, this sum plus this sum. So it will be sum before e minus 1, and after that e from n, and it will be the full sum for 0 to n. But if in this case it will be minus and minus before breaks, and in breaks it will be sum from 0 to n, and you know this formula. If qu it is formula binom Newton at qu plus qd to the power n, but qu plus qd is 0, so instead this sum will be only 1. So we have a very simple formula, and it's link between call and between call price and put price of options. Yes. And example, stock is worth 60 today. In a year, stock price can rise or fall by 15%. Interest rate is 6%. And the question is, what is the price of call option that expires in 3 years and has an exercise price of 17? So from this, what we have SS060. From this, we can find U and D. U, it will be 1.15, and U, it will be 0.85. Interest rate 6. Strike price 17, and time to maturity 3 years. 3 years. And if we know all of this, we can find find PU and PD, PU and PD, and it is what from this formula. Yes, PU and PD are we know, U and D we know, and QU and QD we can compute, and you know this formula. So first Q, U and QD, and it will be these values. After that we compute PU, PD. After that index K0 according to this formula, and after that you see that it is 2.19, but we need integer value more than this, so it will be 3. And after that we substitute in formula Cox-Ross-Rubinshtane. Have you any questions?
Yeah.
No.
Can you can you explain why we take logarithm to find what?
This logarithm, yes?
Yes.
Because we use this formula, logarithm from this divided by logarithm from this. But how this logarithm appears, it is if you repeat school algebra and solve this equality, and it will be sure. So logarithm, yes, this divided by logarithm of this. Have you questions else? Thank you. And now we should find out what's replicating strategy and how we can use replicating strategy for the aim of pricing European call option. So on this slide you see binomial 3 period, yes, binomial 3 in the black color, and in the green color it is call option 3, call option 3. And now we would like to deal with trading strategy. For this, let xt denote amount of units cash between time t minus 1 and t, and y t denote amount of shares held between this time. Yes, x and y, x and y. So on this tree you can see in black color stock price, in blue color option price, and in the this square bracket you can see replicating portfolio. Let I recall you what is replicating portfolio. We construct portfolio and portfolio from cash and stock and stocks only, cash and stock, and that's all. And the idea is that the value of this portfolio equals your function of option. What is that's idea, and we would like to compute backwards. So for time equals 3, we know for your function, you see, for your function, and we would like to find xt and yt. For this, we should to write and solve the system xt multiplied rt, where r capital is 1 divided by n plus r little. It is no discount factor, and yt multiplied this value 122 and 5, and it will be 22 and 5, but it is for up scenario, yes, for up scenario this, but for down scenario, so this system for this one period, so this system for this one period 3. So it is cash, so multiplied RT. It is amount of stock multiplied 122 and 5, and it will be this. So its value of portfolio in the up scenario, but idea is that value of portfolio equals payoff of option. This it is value of portfolio. It's a down scenario, and it is payoff function of option. And if we solve this linear equation, it will be xt minus 97 and yt is equal 1. So we write this. Have you any questions for this for this one period system, one period model, and how we can find replication portfolio? Is just as for one period model in your home problem set. In your problem set, so we have one period model, we construct portfolio, and the idea is that the value of portfolio equals for your function of option. After that, we consider the second one period model and the third one period model, and so on. And if we have done all of this, so the initial time moment of time, we have this portfolio, initial portfolio, and if we find initial value of portfolio, it will be the option price, fair option price. And we can compare that it is really true. And what is interesting that if we find, for example, if we consider this upper node, and we compute the value of portfolio just before this time, So for this, we this value multiplied 107 because it's just before, and this value multiplied multiplied discount factor, and it will be 10.23. But if we compute just after this time, so now we use this portfolio, So with this amount multiplied 107, not this, yes, but this, and this value multiplied discounted factor, but the value 10.23 are the same. So it's interesting because the value of portfolio just before time and just after this time are equals, and it calls self-financing trading strategy as self-financing portfolio. And you can write this proof. So that's all, and that's all. Maybe you can read this by yourself. So summary. What we know after today's lesson. After today's lesson. After today's lesson, we know the rule how we can construct the binomial, multi-period binomial model, and this rule is for every node we can this formula, and probability for every node we can find using this formula, and risk neutral probability defined as these expressions. So it's first. After that, we learned how we can pricing a European call option using method backwards. For this method, maybe we can use Excel, and after constructing binomial 3, the first step it is we compute for your function, and after for your function we applied a formula for fair price for one period model, yes, and it is for all values in this column. But after this we use this value, and so on. So from back to initial. The second way, it's only multiplied the value at the exercise time, but by probability at the final time. And for this, we can get a Cox-Ross-Rubinshtane formula. How we can use this formula? We can know QU, QD, PU, PD, and index from this sum. And you should know about replicating strategy, how we can construct portfolio, and how we can find this portfolio for any node, and get the initial portfolio, and the value of initial portfolio is fair or fair option price too. And it is a self-financing trading strategy because the value just before every time equals the value just after this time. Uh, and that's all. And if you have any questions, we can discuss this on the practical lesson. Okay?
Yes.
So, see you.